I'm Luke Kelly. I'm feel very fortunate to be a Trout Unlimited staff. I'm based in Olympia, a little closer to Nisqually River. And I work from home. I do restoration projects, most of my projects on the west side of the Olympic Peninsula, and also in the Chehalis. I'm really excited to share, and most of you may know by now, that we have a new staff dedicated to the Chehalis Basin. So we have a Chehalis Restoration Project Manager now. Her name is Alex Gustafson. And she's had the BAT training, and she's doing great things already. I've met many of you, and whether I've met you or not, I really want to start out by saying thank you to all of you that are on this call. If you're on this call, I assume you're on the BAT team or intend to be. And I think it's a really, really cool program. It's already done good things, and I think it takes a lot of hands to do what we're trying to do. So thanks all of you for participating in this. So today we're going to talk about, as part of the barrier assessment protocol, Department of Fish and Wildlife barrier assessment protocol, there is a fish use potential metric, and we have to decide how to call that. And then there's another thing I'm going to add on here, which is somewhat related, which is significant reach. It's pretty clean cut. I think it'll go pretty quick, but I just have some slides we'll run through. If it'll let me go here. There we go. As I mentioned, this is part of the protocol. They have all these different chapters. Essentially, the fish use potential metric is in the site information form. That's the first form when you get to a barrier site that you pull out, and that would be covered in Chapter 2. So there's language that I copied and pasted from Chapter 2. You'll see in a minute as to what fish use potential means. And then I also mentioned the significant reach, and that is on level A form, and that's covered in Chapter 3. So all this information, if you wanted to go back to, it would be in Chapter 2 and 3 of the protocol. So here we are. There's probably a little bit of a lag, but you should see site description field form. You see the red circle here, fish use potential and fish use criteria. Basically, if you are going to select a fish use potential of yes or no, you need to indicate which criteria you use to make that call, and we'll get into that now. So this is actually cut right from Chapter 2 in terms of definition of fish use potential. I don't need to read this word for word, but you can see what I've highlighted here, and this is talking about fish use potential. It doesn't mean that there has to be fish present. It doesn't really even mean that there's been past documented fish use there. What it is potential for fish use if we take out any man-made barriers, or if fish were able to access the stream, is there potential that they could use it, like there's no natural barriers in the way. So something to keep in mind. That second line at the very end, it says fish use potential is not restricted by man-made barriers. So something to keep in mind. Fish use potential, yes, no, or unknown. I'll say this a couple of times. When in doubt, just select unknown. A lot of this stuff we can figure out later in the office, or making a couple phone calls to folks that know the landscape. So when in doubt, you can always select unknown. But if you're pretty savvy and you're pretty excited about your stream, which I often do, you have three options. This is a hierarchy. So basically, if biological, you actually see salmonids. That could be resident trout or baby salmon or adults, of course. If you actually see them, that's kind of the best. You know, that's a confirmed presence while you're on site. Next would be mapped. So that's, you know, kind of a desktop analysis, looking at maps to see if there's been any documented fish use. And then we have physical, which is basically the stream width and the gradient. Can fish get there? Can fish use the habitat? Or is it just too steep or too tiny of a stream, essentially? It's kind of limited by the size on the lower end of the scale. And then other. And other could be a multitude of things that you can imagine. We're still finding fish in places that weren't documented before. At the bottom, you'll see potential includes spawning, rearing, and refuge habitat. So sometimes you could even have an off-channel wetland that's connected to a culvert, but the main stem river is really, really far away. They may not even have connection now. It looks like the wetland is an isolated pond, but certain times of years, it could rear fish. You know, coho really like that kind of habitat. So just something to keep in mind in terms of potential. So we get into some resources here. The protocol does call out the second one, the DFW Salmonscape map. The very first one is kind of my go-to, NWIFC is the Northwest Indian Fisheries Commission, and we call it Swifty map, which is the statewide integrated fish distribution map. This is great and basically has just as much data, if not more, than the DFW Salmonscape map. For our purposes, you could trade one for the other. Either one is perfectly good, and I'll show some examples of that. We can get these links. I think a couple of them, Nick, you might be able to answer this, might be on the site, and if they're not, we'll get them on the BAT site.
I will 100% put them on the site.
Great. The third one here is basically the Department of Natural Resources Forest Practices map. This is based on forest practices, and they also have a fish use, or more like a stream typing, a fish versus no fish stream. And again, those could be resident fish on this particular map, and I'll talk about that. In fact, I'll save that until we get to the map, and I'll talk about a little bit of the detail there. I made a note too on the bottom that all three of these maps and many of the stream maps, even Google Maps that we use often for other things, rely on NHD data. NHD is the National Hydrography Dataset. Essentially, that's where we have map streams. And here I put blue lines on the map indicating streams. But on Western Washington, particularly where it's so wet and there's water everywhere, it's amazing how resilient these fish are and what they'll use. There are a lot of sites that have a stream and there's no blue line on the map. So just because your particular site you're looking at is not on an NHD line when you look at these maps, doesn't mean that it might not have fish. So then in that case, you know, if it's not on an NHD line, you can't use a mapped kind of documentation criteria, then you go to the physical criteria. And this will make sense in a minute when we actually talk about those criteria. Moving on, just some examples of each of those resources. By the way that they're presented, the Swifty was first, and you have the link there. But basically, there's layers on this map, and you really want to use the documented layers, or really the key. So they're all shown here. It's kind of hard to see. I don't know if you can see my cursor. Yeah, you can, it looks like. So you see the documented presence, documented spawning, documented rearing. The blue, maroon, and green colors are what we're looking for. Now, just below that in brown is presumed presence. That could be modeled multiple ways. There's also in purple, potential presence. That's likely modeled or could be fed by local knowledge. I would shy away from those, but if you find your site looking at this map and it is documented presence, spawning, or rearing, yes, fish use potential. That's easy. That's a really easy one to go for. So there's the Swifty, and it's fun to play around with this too. There's a lot of information here, especially when you start zooming in. Okay, and then here's Salmonscape. I try to grab the same area. The layout is a little bit different, but you'll see documented spawning, documented rearing, documented presence, and then they still have presumed presence. I don't use Salmonscape as much, but essentially it's going to give you the same data. And then the last one is the DNR Forest Practices Application Mapping Tool. And before we look at an example of that, I put a description, or more rather a definition of what these stream types are. So the map you'll see on the next screen is going to show colored lines, and it's going to have letters on them, F, F, NP, or NS. We're looking for F and F. F is a shoreline of the state. So generally those are larger streams, navigable streams. And if it's an S, it's generally going to be a salmon stream. If you run into an S stream that may not have native trout and salmon, let me know. I'd be really curious, because I don't think they'd be hard to find, let's say. Type F is a go-to. And to note on type F, they're fish streams, so they're not necessarily anadromous fish streams. A lot of resident trout, even if they find a sculpin, they will designate that reach of stream an F stream. So that's, again, related to forest practices. Here's the map. And when you open this map, it's kind of hard to see where you're going. It doesn't have a very good base map behind it. So a quick tip is right away, if you see my cursor, these 4 little boxes, that's your base map. When I open the map, there's like a splash screen. You say, okay, and I go right to the base map, and you can do a kind of a basic topographic map. There's lots of options. I use imagery like you're seeing here. But you'll see I pulled up, this is an area just south of the Hoh River. We actually have a project going here on Owl Creek. And Owl Creek is an F, so it's a shoreline of the state. So when it comes to me doing permitting and such, I'm going to have to work a lot more with the local jurisdictions, let alone state and federal, versus an F stream is a little more straightforward. But this red is F, so we have fish here, we have fish here. But if you were surveying a culvert on one of these green lines, right now it's designated as a non-fish stream. I love, when I've had the opportunity to survey many culverts, I love to just look around. I approach the stream as I'm near the culvert very slowly, almost like you're fly fishing, and see if you see any fish. Because if you do, it can really trigger changing some of these green lines to red lines, and that, you know, helps with forest practices too. So the DNR map is great, and you can use it for multiple purposes. It's got good information, and again, there's some things you can toggle on and off on all of these maps to look at different layers. Okay, now we're moving to physical criteria. So you don't see fish. It's not on the map. It's either a no fish or it's not on an NHD or what have you. So you have to use physical criteria. As you can see here, Eastern and Western Washington have different thresholds on stream width. And again, we're talking about scour line width, not bank full width. Bank full width is an important metric when thinking about streams and our culverts and such, but we're really talking about scour line width. So there's a little bit of a refresher coming up on that. And also gradient. So, you know, scour line width essentially is going to capture the size of the stream in terms of width. And then gradient is important to note, of course, if the stream gets too steep, certain species can't make it up. And at some point, about 20% no anadromous species or resident species can progress upstream. In our training via the WWW protocol, you might not be able to measure a natural barrier, and you're not intended to. So here I put sustained gradient of 20% plus for at least 160 meters. That's going to tell you if it's a natural barrier or not, but we're not really charged with doing that. What we're doing is just trying to identify if the site we're standing on at this culvert has potential. When we get into the significant reach, we'll talk a little bit more about the 20%. But obviously, if you're standing at a site and you see a very steep section of stream immediately below or upstream from the culvert, it's definitely worth noting. You can estimate gradient if you have your rangefinder. There is a way to calculate that. I don't think we need to go there. I think that's a little too much. But anyway, sorry to talk too long here, but just to soak in this slide, that's the physical use criteria in terms of potential fish use. So again, quick refresher on scour line width. This is pulled directly from the training. It's going to be below the bank full width. Here's another image. Something to consider, Western Washington, where we do get a lot of rain. Oftentimes the scour line width will be very close to the bank full width because we're basing it on a normal high flow event for that season. Actually, that last slide, let me back up. It's important. I'd like to say this. Includes everything within the active channel where stream flow would be expected during regular seasonal high flows. So if you can imagine, if you're in Western Washington, or even if you know your stream in Eastern Washington and it kind of jumps its banks and floods every winter, or spring for that matter, just consider what a scour line width is. So we're talking about scour line width. Another refresher here is to measure scour line width outside the influence of the culvert. So the image below on the right side is the outlet and like the scour pool below the culvert. And the upstream end on this particular image shows a sediment wedge. And what can happen there is if a culvert's undersized, the sediment coming down the stream will settle out at the culvert because it's too small and it'll pond up, and that ponding lessens the stream power and a lot of sediment will settle there, and you make this sediment wedge. And you, again, just try to stay out of the influence of the culvert when we're measuring scour line width. That's about it. Now we're moving on to the level A form. There's only 2 slides left here, but significant reach is somewhat connected to the fish use potential. Yes, no, or unknown. And significant reach is defined in the protocol as a section of stream having at least 200 linear meters of usable habitat without a gradient barrier or natural barrier, both upstream and downstream from the fish passage feature. Of course, 200 meters upstream and downstream will need to have landowner access. Another thing to consider, if it's not mapped in terms of any of those resources, we're going to have to use physical criteria. That Scour Alignment width and a gradient less than 20% to call it usable habitat. I also put time of year, and there could be probably other considerations, but a couple of photos below just kind of show the stream on the right side. The photo on the right side is a pretty large stream, but it just goes dry for about a mile. But it's used by coho and everything. And there's a big barrier there that we're pretty interested in. We're keeping an eye on it. But that gets a lot of fish use. And you go there in July, and you could walk up and down. You could think, wow, there's obviously water here at some point, but how do I call this? And my point in explaining this is this particular stream is not, it's on an NHD line, but there's no documented fish use, but we have found fish there. Use your intuition. When in doubt, select unknown, but maybe put it in the notes. Put some stuff in the notes on this stuff when it comes to potential fish use or significant reach, because that can really help. To kind of further go down that rabbit hole, the picture on the left is a tributary of the Hoh River. And at this point, this is about a 0.29 meter drop because of a large log. It's a very old log. And if you think about our culvert water surface drop threshold, it starts becoming a barrier at 0.24 meters. So this log, on a certain season, could be somewhat of a barrier. It not being a culvert, it's not a barrier. And you go back here right now, when the coho are coming in, they'll get right over that. In fact, they'll be able to swim over it with the amount of water that's in there now, probably. So just things to think about, but always, when in doubt, just select unknown. That won't really make or break the barrier status or, how quickly it could be prioritized. And I think that's what I have. So I'll just open for questions, please. And thank you.
Thanks, Luke. I had one question. When you're looking at when you're looking at physical conditions, when you're looking at the scour width versus and the gradient, do you have any good tips on how you would do looking at the gradient, whether or not it's 20% or less, when you're in the field?
Yeah. It would be great to, I always like to get calibrated with 20%. So I'll try to find 20%, but I have my laser rangefinder, which can shoot inclination. I don't know that we want to go there today, Nick, but it's great if we could find an example stream reach that's 20%, and you have to be on the ground to see it. Like seeing a picture of it doesn't do it. But when you can kind of, like most things, you can say, okay, that's 20%. You can kind of get that calibrated in your head. And it's relatively rare. I don't want to say it. I mean, they're 20% plus gradient is in a lot of places. Generally, they're far up in the watershed, and you're going to be scratching your head like, are fish going to be living here? Tips otherwise. So what we do in terms of habitat surveys is we use our laser rangefinder, and I am 6 feet tall, minus my eye. So what I will do is I will stand on level ground with my survey partner, or you could use a stadia rod, which has markings on it, and you could set the rod in the channel as some vertical location, and you're upstream or downstream, and you shoot, like I would shoot 5 3/4 feet with my laser, and boom, it gives you the gradient. And that's in percentage versus like degrees. So it's always percent, 20% or what have you.
Got it. Thank you.
It seems like it'd be a challenge to do 200 meters upstream and downstream.
Because of land ownership, or?
Well, I mean, where we were shooting in the Green River, or the White River watershed, Greenwater River watershed, up, and it was a thicket. So
yeah,
it would have been a real challenge to try and get 200 meters upstream or downstream.
Yeah. In terms of like shooting gradient, you wouldn't have to shoot that far, but just actually getting through the stream, I'm not sure what you're referencing there, but yeah, that's often in terms of trying to get a laser shot, it's really hard. You'll never get 200 meters, but yeah.
So just
What we have done, just to be fair, is we did an inventory for the county, West Clallam and Jefferson County, where we walked and we did a bunch of level A surveys and didn't do level B. And we went back and looked at all of our data and said, okay, which one of these, even though, over 100 of them called for level B, which one should we actually put the resources in to go do a level B? And we went back and did that. And even at that point, we still had significant reach unknown if it wasn't mapped. And then when we got our priority out of hundreds of culverts, okay, these 50 are really important. And if we couldn't identify significant reach or fish use potential at the desktop, then we went out and we did the 200 meters thing. So it's not a deal breaker on our surveys and your surveys. I think, it's okay to go unknown, but it is important to know, what we're looking for, like what these metrics mean in terms of the protocol.
Thanks, that's encouraging.
Excuse me, I've got a quick question about the use of the Salmonscape and the Swifty maps. Are they considered very reliable? In other words, if we don't see something, but it says on the map that whatever on the map says, I'm going to say it is there, but we don't see it, does it make sense to say it is got this potential based on the map?
Sorry, Steve, I want to make sure I understand your question.
Sure.
The maps are relatively dependable when it comes to fish use, like the documented fish use.
Mm-hmm.
But if we're talking about particularly like that NHD, the stream lines, there's a lot of streams that have no blue line, and that is where the maps fail us. That's where we got to just go forward anyway. If we have physical criteria, go ahead. We found many streams that are not mapped on these maps that have fish in them, including anadromous fish. Where I am, I'm in the pretty wet area, but I hope did I answer your question?
That's half of it, and the other half would be, in other words, if we don't see something, but on the map it says they do see it, can we just say yes based on the map?
Absolutely.
Okay, that's it. Thanks.
Yep. Yeah, that biological criteria in terms of the hierarchy is rarely checked.
So,
usually you're checking mapped or physical.
So Luke, I guess this is Scott. So a follow-on question to Steve. So Carl and I were doing some assessments earlier this spring in an area where it looked like there should be fish, but we didn't physically see any fish. But the neighbors said that they had seen fish in previous years, but not over the last couple of years. If that makes sense. We marked them as fish potential because the people said they were there, and the historical data said there were fish. But did we do the right thing? I guess I'm leading up to.
Yeah, absolutely. That could be an other. If you have them, if you didn't see any, but they're mapped, check. Yes, fish use potential every time. If you didn't see any, it's not on the map, but a landowner told you this. And I love to ask, they were salmon, like you saw adult salmon, or you saw trout, were you catching trout? Like try to get a sense of what they were. But no matter what, if you have that situation where you don't see any, it's not mapped, but you have local knowledge, I would absolutely note that, and I would probably put a yes. You could put unknown, but then your note might get missed. Like those kind of notes and that type of information from somebody very local on the ground, to me, is extremely valuable.
So mark it as yes for fish potential, and then put a comment that per landowner XYZ whatever.
Yeah.
Okay.
Jim, are you talking?
So I guess
You muted.
while we're sitting here with the silence, so 20% gradient seems extremely steep. Given that I don't know how many roads exceed 10%, which would be it'd be pretty obvious to me, I would think, that it's approaching 20%. Am I missing something in that?
No, it's 20% is very steep. You know, you can kind of imagine what a 45-degree angle is. You know,
Yeah.
you take half of that and you add water, and that is usually those are steep, bouldery bedrock streams at that point. You will see very few gravels, maybe in the plunge pools, but it is very steep. And it's amazing how capable the fish are too. Particularly like summer steelhead, they'll use pools and stuff almost that steep, but it's generally pretty rare where you have a 20% sustained gradient and you put a road right across it. I mean, up at like side hill roads, high in watersheds, like in the Olympic National Forest, it's somewhat common. And sure enough, most of them don't have fish in them, including just little tiny resident trout or sculpin. There is a natural barriers training. There's also habitat assessment training. Within the manual, within our barrier assessment manual, there's a lot more discussion on that, on kind of the natural barriers, or like what that 20% gradient means. It even has a table on the leaping abilities per species, assuming that they have a nice deep pool to jump from. So they can actually go little kettle pool by kettle pool to get up certain areas. Yeah, it's just amazing what some fish are able to pass through, but generally not very often we run into that 20% gradient threshold.
This is Carl here. I guess more of a comment in terms of the 20% gradient, and then you made a comment about natural barriers. You look upstream or downstream, over the couple hundred meters, you may have 20% or so, but in there, it's sort of a non-linear, if you will. You have big drops and then flat areas and that kind of thing. So it seems like more of a comment that you got to think about natural barriers when you look at this gradient idea, because the two go hand in hand.
Yep, good point, Carl.
Jim, do you have something you're trying to say? I see his box lighting up.
Not me. No.
Oh, okay, cool. We're good. Well, anyone have any other questions? Everyone feels confident going out in the field and making these decisions? I think the for me at least, the fish use the mapping ones are going to come in handy for me. I think I was intimidated by them at first, but now I think I'm definitely going to utilize those a lot more now that I've seen what they look like and how easy it is to utilize. So I'll make sure I put those resources on our website so it's easy to find.
So Carl here again, this kind of maybe I should know. You can overlay these fish use maps and the culvert stuff in some of the layers, right?
Yeah, that's a really good point. That's a good point. They pull in Salmonscape into DFW does in their barrier database. You can actually turn those layers on our barrier database, the statewide one that we access.
Okay, I guess I'm have to fool with it. I think I've done it, but I don't remember right off the top of my head.
I can try and make a tutorial video on how to do that.
Oh, that'd be great.
I have to figure it out first, but I think I can do it.
Hey, I guess I've been thinking about this. So the question I have is when I go to enter the data, right? I always look at the last information that was recorded for that culvert or that site, right? And oftentimes it will say that it has fish use potential or not, and it'll give the criteria, right? And I will admit that there have been times where I have filled out the current assessment using that old data, just copying it over. Should I do that, or should I go to one of these? If I didn't have the biologic site, should I go to the map first and verify that it's still recorded on the map, as opposed to using the historical data that was filed against that culvert? If that question made sense.
That's a great question. I would assume, because we're talking about fish use potential, and if there's been documented potential in the past, unless there's a major earthquake or there's been a major diversion to the stream or something, I would think, yeah, it remains the same. You probably would not need to go into the maps and check again. If you wanted to be thorough, you could, but yeah, that would check the box for me, Scott. That makes a lot of sense. That's a good question.
I'll follow that up. Some of the culverts that the guys were doing over in Greenwater, Luke, were last surveyed by the Pierce Conservation District in like 1999. Do you know, I know, right? has fish use potential surveying, like looking at that, has that changed drastically over the last 20 years to a point where we might have to worry about that at all, and where we should be checking the maps to verify 20-year-old data?
That's great. Great question. I would say, by definition of the protocol, potential, I don't think you need to, but yes, I would recommend it. I'm lucky I get to do this. So I'd scrape up all the data. If there's a site I'm interested in, I want every piece of information, all the landowners to tell me what they know. But if you're spending your time doing this, technically speaking, you're doing it by protocol. I'm making the call here. This is kind of a gray area, but I think if it had yes fish use potential on a previous survey, you could probably call it fish use potential. But the point you bring up, Nick, is really good. That could be valuable on certain sites. Before it has fish use potential physical criteria, the lowest hierarchy. And then you go to the map, and since then, there's documented spawning. Your fish use criteria is going to be even better than the previous. So there's an example of you just, connected the dots to improve the data. Good questions for sure. The protocol, it's supposed to be in black and white, but nature is never at right angles. So you got to use your judgment, and we do want to get good data though. And if you can look at the old site information and you look at the map and there's a change and you could capture that, because nobody else is going to capture that. DFW Fish Passage Program does a great job. They're great partners, but they're busy and they can't really cross-reference all that stuff. They're not on site like you guys are doing. So really good points. Yeah, just take a minute. Probably should have done this at the end of the slides, but those that watch the recording are going to get extra tips and tricks in the end. Little reward. Let's take it off of this one. Just a minute here, guys. Okay. Here we go. Okay. So I assume most of you have seen this. This is DFW's statewide database. And, this layer list on the top left is where we're going. That's where I am now. And down here, see fish distribution. We're going to select that. Now everything turns purple, but we want more detail. So I'm going to hit the little toggle down the little arrow points to the right. I point that and it toggles down. Look what shows up here. It's not Salmonscape. I misstated that. It's Swifty is on this. I'm so glad that you connected that for me. And then you have fish distribution. So this is a really quick and dirty way to see if there's documented fish. And you'll remember when we looked at the Swifty map itself, you could look at specific species. So here we have purple. Let's get where's the legend? Is there a legend? I guess this is our legend here, the purple line, fish distribution. So since I have a screen share going, I think I can go right here to Swifty. Yes, it's going to work. There's a splash screen. And the layer list is here. It's already highlighted. You can see layer list. I think, yeah, you guys should be able to see that. Now I'm going to go, look at this here, Hydro NHD. When I turn that off, all the blue lines go away. At least they should. I have fish distribution on. We don't want other fish. We're going to look at salmon and steelhead. I'm going to toggle down. And you see all the species? It's kind of cool. You can turn them all on or off, essentially. But just for show, let's look at winter steelhead. And you see this is where you get all the more detail, documented presence, spawning, rearing, etc. Let's zoom in. Let's see here. Steelhead. Just zoom right into Kent a little bit. And we're going to select winter steelhead. And it might take a minute to load. But yeah, here we go. So some of these are overlays, documented presence and spawning and rearing. Where's some green? I'm looking for green here. Sometimes zooming in will give you more detail. We're in a pretty urban environment right here, so that might be what we have. So if I take steelhead off, you'll see what's going to happen. Something else is still highlighted. What do we have for red? There we go. I have the DNR water types. So look at this. This is also on here. Type S, type F, type N. So you got to be careful to make sure if you have too many layers on at once, because they're using same colors, red versus what have you. But right here on Swifty, you can go and identify both and make note of that. There's definitely some overlap, as you can see. If I were to recommend anything, I would recommend Swifty. And then if you want to go the extra mile, you could look at, okay, there's no anadromous fish here, but is it a type F water? Have there been documented fish here in terms of forest practices? And you could use this map. I usually use the actual DNR map, but get good resources. One more thing. Here's the DNR forest practice map application. And as I was talking about, the first thing I do is I go in here and select the base map. And just for clarity's sake, let's do topographic instead of imagery. And we'll zoom in here. And if you look at to the left, you can see a lot of information. Section, township, range. They have kind of large scale boundaries. But it can get kind of busy, so I often turn these off. And what we want is the stream type maps, and here we go. So they're already highlighted here. We have red is F, fish streams, green is N, no fish. If you ever got excited about a barrier and there wasn't really good information, this is where I often go. I have ArcGIS, fancy software, but this little wrench, you can measure. And we can go miles, different units. But basically, you can find your culvert, and these streamlines, these NHD lines with the overlay of color, you can measure approximate fish use upstream in terms of resident and anadromous fish. So again, that's getting into the weeds a little bit, but I'll often go here if I'm trying to develop a barrier project and I want to know how much potential habitat is upstream. I will try to pull from all these sources, but what gives me the largest number documented is this, because it also includes resident fish, and I can measure, if we fix this, we get 2 miles of habitat gain or what have you. But there's you can get lost in here. It's pretty fun. I'm always impressed at technology and how it all works. And another tidbit, since we're talking technology, if you just Google WA DNR LIDAR portal, LIDAR, LIDAR is like infrared survey from the air, and it can penetrate canopy, and basically it shows the actual ground topography to incredible accuracy. And it's amazing. So for example, you go to LIDAR portal and you can just surf around a map of your area, and you can see glacial striations on Puget Sound, where the last ice age, will advance and receded and literally scour the earth. Anyway, I have no link for that, but the DNR LIDAR portal is amazing technology that they use with LIDAR survey technology. And that kind of gives you can really see the ground, the lay of the land with all the trees and stuff removed. They also use that too, the first return LIDAR, because it shoots like 200 beats a minute or a second, really, really fast. And the first return shows where the canopy is. You can actually get tree height. You can overlay ground bare earth and you can actually estimate forest canopy, and they use that for old growth forest surveys. Anyway.
With the right post-processing software, you could have the 3D image displayed and actually calculate the gradient without ever going into the field.
Yeah, that's right. We use LIDAR a lot on some larger streams. Really, really helps. And like a lot of like the off-channel habitats, the little side channels and things that are hiding and tucked away, they just appear on LIDAR. And people have been on the ground for 20 years, and they're surprised sometimes. You can't put your feet everywhere, but yeah, LIDAR is something.
And it's getting cheaper all the time. The latest great iPads actually have a LiDAR camera as part of the base package.
Really?
Yeah.
Can LiDAR my lawn.
Well, again, you're going to have the right post-processing software to make it worthwhile, but that's not very far down the road.
That's amazing.
Well, awesome. Does anyone else have any questions? No? All right. Luke, thank you so much. We really appreciate it. I'm going to finish this recording, and then we'll get it posted on the website, and it'll be a requirement for any future BAT trainees that they watch this, just so they can get a little bit more in depth and really understand what they're going to be doing. So I'm going to stop the recording now unless anyone's got something important to say.
Thank you, Nick and Steve. I know Steve's behind the curtain there. You guys are awesome. I just cannot tell you how thankful I am you guys put this together. And look at the team. I mean, this is awesome. Thank you.
Thanks.